Hello students, this is the answer video for question number 2 for classwork number 1. Let's get started. The function f is differentiable on the closed interval -6 to 5 and satisfies that f of -2 equals 7. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments as shown in the figure above. Find the values of f of -6 and f of 5. Part B, on what intervals is f increasing? Justify your answer. Find the absolute minimum value of f on the closed interval -6 to 5, justify your answer. And D, for each of f double prime of -5 and f double prime of 3, find the value or explain why it does not exist. So let's get started. Part 1 asks me to find the value of f of -6 and the value of f of 5. The big thing you need to realize here is that this is the graph of the derivative of f. So if I want to find f of -6 and f of 5, I'm going to have to do an integration. All right? Because we have an integration, that means we're going to have some type of foundational point that's going to say, okay, this is absolutely true, and that's going to be my f of -2. So if you remember in the last video, we said that since we have both of these, we can say that the integral from -6 to -2 of f prime of x is going to equal f of -2 minus f of -6. Now this allows us to solve. We have an equation now involving f of -6, so we can solve for f of -6. So we want to do the integration from -2 to -6. It's going to be from here to here. -6 to -2. And that's going to give me a 2 by 4 triangle. So that means the area is 1/2 2 times 4, or just 4. That's going to be 4 equals, and they told me that f of -2 is 7. Minus f of -6. So I bring over my 7, that's -3 equals negative f of -6. They're both negative, so you end up getting that 3 equals f of -6. So we do the same thing to find f of 5. Well, we're going to set up an integration from the only thing we know, -2 to 5 of f prime is just going to give us f of 5 minus f of -2. Again, we know f of -2, so that's going to be 7. We're going to have f of 5. Now to find the area, you need to find the area between -2 and 5. That's going to be this whole area. And one thing that's important to remember, this is underneath, so the area is going to be negative. This is above, so the area is positive. And we have two shapes here. This first shape is a semicircle. So the area equals 1/2 pi radius squared. And this is a triangle, so area equals 1/2 base times height. I can write that a little bit cleaner for you. Area equals 1/2 pi radius squared. So again, this is going to be a negative area. Give me some space. It's going to be negative 1/2 pi r squared plus 1/2 base times height. My radius for my circle is 2, so that's 1/2 pi 2 squared plus 1/2, and this is a 1, 2, 3 by 2 squared, 3 by 2 triangle. We can see that now we have our equation. We have f of 5 and no other variables, so that means this is going to give me a value, and that's the answer we want. So that's going to be minus 2 times 2 is 4, times 1/2 is 2, so minus 2 pi, plus 2 times 3 is 6, divided by 2 is 3. Bring over that 7, 3 plus 7 is 10, minus 2 pi equals f of 5. And this is actually a really good question. I really enjoy this question because you have to do a little twist on integration and understand the areas. And maybe it's my geometry teacher in me, but I really like this question. So for C, on what intervals is f increasing? Justify your answer. Now remember, in order for f to be increasing, that means f prime of x is positive, is greater than 0. And since this is the graph of f prime, this is actually a really simple question so long as you understand what you're looking at. That means everything we're looking at is wherever it's above the x-axis. So that would be then f prime of x is greater than 0 from negative 6 less than or equal to negative 2. Nope, sorry, less than or equal to x less than or equal to negative 2. And from 2 less than or equal to x less than or equal to 1, 2, 3, 4, 5 less than or equal to 5. And now they want a justification. Well, that is the justification that f prime is greater than. So you say therefore f of x is increasing on those intervals. And that would be a good answer. Nice and short. Now question C. Find the absolute minimum value of f of x. All right, since we're going to be doing a minimum, it means we're going to want to do a domain check. So we have in order to find a minimum, that's where f prime of x goes from negative to positive. So we're looking at f prime of x. We can see here we have positive values. Well, actually, we don't know what's happening over here. Sorry. But then from here to here, we have negative values. Here we have negative values. And then here we have positive values. And here we have positive values. So the only time that f of x goes from negative to positive, so therefore, since f prime of x only switches from negative to positive at x equals 2, our minimum is at x equals 2. Now that's not enough. They actually want the absolute minimum. So that means we need to find f of 2. We're going to use the same technique we used on the first one. So we're just going to do an integration from negative 2 to 2 of f prime of x, because that will equal f of 2 minus f of negative 2. And we know that f of negative 2 was just 7. So now I just need the area from negative 2 to 2. You can see that'll be a semicircle. So the area will equal 1/2 pi r squared. But there's something you need to realize. This is underneath the x-axis. So this is going to be a negative area. It's going to be negative 1/2 pi radius squared. If we look up, the radius here goes from 0 to 2. So r equals 2. So that's going to be negative 1/2 pi 2 squared equals f of 2 minus 7. So that's going to be negative. That's 2 times 2 is 4, divided by 2 is 2. So negative 2 pi equals f of 2 minus 7. We're going to bring that 7 over. And let's get 7 minus 2 pi equals f of 2. So this is our minimum. So D says for each of f double prime of negative 5 and f double prime of 3, find the value or explain why it doesn't exist. Now that should be a big answer that one of these is not going to exist. So let's see what we're looking for. Well, f double prime, so we're given f prime of x. So f double prime of x, we're looking at the graph, is just the slope of the tangent line. So f double prime at -5, that's -1, -2, 3, 4, -5. That's right here. We have an obvious slope there. That's going to be my vertical component is up 2. The horizontal component 1, 2, 3, 4, and it's negative. So that's just going to be -1/2. That was pretty easy breezy, lemon squeezy. So this one may be the one that doesn't exist. Let's check it out. Well, f double prime of 3. Okay, we can see here, we call that a corner. And so we know this already does not exist. But they want me to explain it. So I don't know if the AP exam is going to be sufficient with saying because it's a corner. So what does it mean when something's a corner? Well, for it to be a corner, that just means that the limit as x approaches 3 of f double prime of x does not equal the limit from the right, does not equal the limit as x approaches 3 from the left of f double prime of 3. And this is a good enough answer. If you wanted to check it, you can see over here we go up 2 over 1. So that's going to be a slope of 2. And here we go down 2 over 2. So that's going to be a slope of -1. That's going to be a slope of 2. And since our limits, since they're not going to be the same here, we can tell that that's not going to work. So again, that's the limit as x approaches 3 from the right of f double prime of x does not equal the limit as x approaches 3 from the left of f double prime of 3. And that's a good answer for question D. Thank you guys. That has been the solutions to question 1 on assignment 2. And remember, I removed question 2 on assignment 2. You don't have to do that. If you would like the video, please ask me and I'll create one, but I've got other things I need to prioritize. Thank you.